Hey everybody, Mrs. KJ here, going over lesson 4.12, the covalent bond and molecules. Many substances that you see around you are compounds formed from covalent bonds. In this lesson, you will learn how some elements combine by covalent bonding, and you will study examples of covalent compounds. You will learn how to name covalent compounds and examine some properties of covalent compounds. Nonmetals share valence electrons. They form covalent bonds. Now you can have a single, double, or triple covalent bond. And the covalent bonds produce unique properties in covalent compounds. Goals for the lesson: describe how covalent bonds form, explain and illustrate how covalent bonds are formed, define molecule, contrast ionic and covalent compounds, given examples of compounds, describe patterns of covalent bonding, including single, double, and triple bonds, understand the rules for naming covalent compounds. And download the study guide if you would like it. All right. Ammonia is widely used in various industries. Ammonia has a number of uses, including many in agriculture and oil refining. In the late 19th century, ammonia was mainly produced from rocks, specifically nitrate ores, and was expensive to make. In 1912, chemist Fritz Haber developed a process that combined nitrogen from the air, which was N2, with hydrogen, H2, at high temperatures and pressure to make ammonia, NH3. Now large amounts of ammonia are made cheaply and efficiently. Liquid ammonia fertilizers increase crop production worldwide. Ammonia is also used to treat metals, neutralize acids in crude oil, treat wastewater, stabilize rubber and latex, produce wood pulp for paper, cure and protect leathers and furs, and clean windows. Covalent bonds are different from ionic and metallic bonds. Ammonia is a compound formed from covalent bonds. It is a covalent compound. Covalent compound: any compound resulting from covalent bonding. A covalent compound is called a molecule. A name applied to any compound whose major bonding pattern is covalent. Note that ionic compounds are not called molecules. Covalent compounds are different from ionic bonds. Ionic bonds form between metals, so groups 1, 2, and 3A of the periodic table, and nonmetals, groups 5, 6, 7A. The metals give up their valence electrons to nonmetals to form metal cations and nonmetals anions. The bond formed is a result of electrostatic, the positive-negative force, right? This is what we talked about last lesson. In covalent compounds, by contrast, the atoms share a valence electron. The formation of a covalent bond does not involve the transfer of an electron from one atom to another. So covalent bond, a bond in which electrons are shared between bonded atoms. All right. So here we have electrons moving freely among silver atoms. So this is just metallic, right? Sea of electrons, sea as an SEA, like the ocean. So we have just pure silver. The electrons are buzzing all over the place, which is why metals are such good conductors. And then, of course, we have the losing of an electron from sodium, the gaining of chlorine for an ionic compound. But now we're going to focus on covalent, which is sharing. So a good example is water. Consider water, H2O. Covalent bonds result when adjacent atoms share valence electrons. Adjacent means next to. This is definitely a word that pops up a lot on tests. So adjacent means next to. Water consists of one oxygen atom and two hydrogen atoms. Each hydrogen atom is covalently bonded to the oxygen atom. The valence electron of one hydrogen atom is attracted to oxygen and interacts with it. At the same time, oxygen's valence electrons interact with that hydrogen atom. While valence electrons are forming a bond, the core electrons remain with their own atoms. The same thing happens between the second hydrogen molecule and oxygen. Valence electrons are shared between the oxygen and two hydrogen atoms. In this way, the outer shell of each hydrogen atom is filled with 2 electrons, and the outer shell of oxygen is filled with 8 electrons. Therefore, the outer shells in each are full. So this electron right here buzzes around hydrogen and it buzzes around oxygen. This electron buzzes around oxygen and this hydrogen. These 2 electrons can buzz around hydrogen and buzz around oxygen. That's how we get 2 for each hydrogen 8 for each oxygen, but if you notice, these inner electrons have nothing to do with the hydrogen. It's all the valence electrons. One covalent bond is a pair of shared electrons. So you have to have one from each because we're sharing, right? Oxygen has to share one, hydrogen has to share one, and that's one bond. A bond consists of a pair of electrons. So water has a total of 2 covalent bonds, one between this hydrogen, one between that hydrogen and the oxygen. Covalent bonds form when nonmetals share electrons. For atoms to be able to share their electrons in a covalent bond, they must have same or similar attraction for valence electrons of their partner atom. That is, they must have the same or similar electronegativities. They must each want the electron. Remember that electronegativity values increase towards the upper right of the periodic table, and of course hydrogen over here. Nonmetals have similar electronegativity values, so nonmetals will tend to form covalent bonds with each other.